Welcome to the stream. My name is Jared, and I sometimes write Ruby, sometimes I write other things. I run a software consultancy where we build e-commerce websites using Ruby on Rails and a platform called Solidus, which is one of the most flexible solutions for building online stores. We're not doing anything about that today, though. We are doing the final day of the Advent of Code. Now, it's been a fun journey. I have never got this far in the Advent of Code puzzles. Usually get busy, life gets in the way. At some point I start making excuses, or one of the puzzles is kind of hard and I don't want to do it, and I fall off. But streaming them has sort of forced me to go all the way through. So we are here now. We have done all the way up to day 24. Day 25 comes out in just a few minutes. As usual, I am working through a whiskey advent calendar. That is very nice looking. This is Two Brewers, which is a distillery up in the Yukon, which was born out of a beer brewery. And this particular whiskey is apparently like they make stout with no hops and then distill it. It is very bizarre. It tastes very, like, you can very much taste the stout flavors. Yeah, I've never had anything like that. It tastes like drinking a stout, except it's whiskey. You get a lot of like banana bready flavors off the nose, and then you sort of get the rich stout flavors in the middle. It's quite something. One thing that came up is the last puzzle was a hexagonal grid-based puzzle, and I tweeted this out as well, but one of the unfortunately, I forgot what the username was, posted some really useful information on how to handle hexagonal grids, and I thought it was really interesting. There's various different coordinate systems that apparently one might use, and as well as cube coordinates, which is kind of interesting because it's like mapping the hexagonal grid sort of as a three-dimensional space. Excuse me. And just like all of these interactive diagrams and stuff, which are just like super helpful. I ended up going with, what grid did I go with? Not this one. Interesting. We can do it two-dimensional as well. Doubled coordinates. Yes, this is what I used when I did the puzzle. Inverted, but so that the coordinates matched, whatever we call it. So that going this direction is going up in both axes. So I don't know. Thought it was really interesting. Definitely intrigued me. But we have. Oh, what's going on? My music is not working. Switch it up, I guess, for this last one. The new year, I will be continuing to stream. I don't know exactly what my streams are going to be. I will likely do one that's based around Solidus. I will also likely do one that is maybe building a roguelike in the browser or something, because I think that would be fun. I've worked on projects like that before, but never got super far on them. And there's also, I also kind of want to do a Ruby stream. There's lots of room for fun there. I just got to figure out what the project or whatever it's going to be is going to be for that. Got to find a format. Right, minute left, almost there. Never done day 25 before. Hope everyone is enjoying their holidays. Or if you're watching this on YouTube later, you know, hope you're enjoying next summer, whatever it is. All right, here we go. Let's get her done. You finally reached the check-in desk. Unfortunately, their registration systems are currently offline, and they cannot check you in. Noticing the look on your face, they quickly add that tech support is already on the way. They even created all the room keys this morning. You can take yours now and give them your room deposit once the registration comes back online. The room key is a small an RFID card. Your room is on the 25th floor, and the elevators are also temporarily out of service, so it takes what little energy you have left to even climb and navigate the halls. You finally reach the door to your room, swipe your card, and beep, the light turns red. Examining the card more closely, you discover a phone number for tech support. Hello, how can we help you today? You explain the situation. Well, it sounds like the card isn't sending the right command to unlock the door. If you go back to the check-in desk, surely someone there can reset it for you. Still catching your breath, you describe the status of the elevator and the exact number of stairs you just had to climb. I see. Well, your only other option would be to reverse engineer the cryptographic handshake the card does with the door and then inject your own command into the system. But that's definitely impossible. You thank them for their time. Ooh. Unfortunately for the door, you know a thing or two about cryptographic handshakes. The handshake used by the card and the door involves an operation that transforms a subject number. To transform a subject number, you start with the value 1, then a number of times called the loop size. Perform the following steps. Okay. Set the number to itself multiplied by the subject number. Set the value to the remainder, dividing the value by something. The card always uses a specific secret loop size when it transforms a subject number. The door always uses a different secret loop size. The cryptographic handshake works like this. The card transforms the subject number of 7 according to the card's secret loop size. The result is called the card's public key. The door transforms the number 7 according to the door's secret loop size. The result is called the door's public key. The card and door use the RFID signal to transmit the 2 public keys, your puzzle input, to the other device. Now the card has the door's public key and the door has the card's public key. Because you can eavesdrop on the signal, you have both public keys, but neither device's loop size. The card transforms the subject number of the door's public key according to the card's loop size. The result is the encryption key. The door transforms the number of the card's public key according to the door's loop size. The result is the same encryption key as the card calculated. Whew, that was a lot. If you can use the two public keys to determine each device's loop size, you will have enough information to calculate the secret encryption key that the card and door use to communicate. This would let you send the unlock command directly to the door. For example, suppose you know the card's public key is 5764801. With a little trial and error, you can work out that that card's loop size must be 8, because transforming the initial number of 7 with the loop size of 8 produces that thing. Then suppose you know the door's public key is something. By the same process, you can determine that the door's loop size is 11, because transforming the initial subject number of 7 with a loop size of 11 produces that. At this point, you can use either device's loop size with the other device's public key to calculate the encryption key. Transforming the subject number of etc. with the loop size of 8 produces the encryption key. Transforming the subject number size 11 produces the same encryption key. What encryption key is the handshake trying to establish? Okay, I'm gonna have to step back through that. Oh, I guess I don't need to copy that. Generating our day 25. So what is my input again? This is the two public keys. Okay. Just call them key 1 and key 2. Okay. I never removed the silly, useless or equals there. Now, is it? It's always the subject number 7 is. Okay. So we can put in our test input. Oops. There's one of them. And the other. Okay, and then this is the resulting encryption key that they would expect. So is it multiplied by itself and then, oh sorry, it was multiplied by the subject number. Yeah. And then return that. I honestly have no idea what the precedence of those operators is. I would expect to be able to do this. I guess I should check. So. To this. Yeah, okay. As expected. What am I actually supposed to call this? It's not count, it's the loop size. Let's call it loop size. And then until n equals key 1, n equals transform n, loop size plus equals 1. Right? Oh, those aren't numbers. Those aren't numbers. Those aren't numbers. Excellent. And loop size. And then, so we transform the other key that many times. So then we go loop. So we'll just make it that. Then we say loop size times do, and we set e equals transform e. Just return e at the end. So that passed our test, and is taking a very long time. Is there some capacity of squaring and to doing modulo math that I should know about? What's going on? Why are so? Yeah, what was that? Oh, it did produce a result. But I hit Control C. Oh, D25 part 2 isn't working. It's running this test. It's taking forever, right? Regardless, let's sneak off with our answer. Put it in. That is the right answer. Continue to part 2. The lights turn green. Oh, I should commit. Also, what is this? Did I like typo this test or something? I don't know what's going on there. Oh, part 1, getting ahead of ourselves. Come on, fingers. The light turns green and the door unlocks. As you collapse onto the bed in your room, your pager goes off. It's an emergency, the elf calling you explains. The soft serve machine in the cafeteria on Sub-Basement 7 just failed, and you're the only one that knows how to fix it. We've already dispatched a reindeer to your location to pick you up. You hear the sound of hooves landing on your balcony. The reindeer carefully explores the contents of your room while you figure out how you're going to pay the 50 stars you owe the resort before you leave. Noticing that you look concerned, the reindeer wanders over to you. You see that it's carrying a small pouch. "Sorry for the trouble," a note in the pouch reads. Sitting at the bottom of the pouch is a gold coin with a little picture of a starfish on it. Looks like you only needed 49 stars after all. You have enough stars to pay the deposit. Although it hasn't changed, you can still get your puzzle input. Okay, pay the deposit. You spend all 50 stars to cover the room deposit. As you fix the soft serve machine, Santa offers you a ride in his sleigh. Maybe the resort has a chimney you can use. Congratulations, you finished every puzzle in Advent of Code 2020. I hope you had as much fun solving them as I had making them for you. I'd love to hear about your adventure. You can get in touch with me via contact info on my website or through Twitter. If you'd like to see more things like this in the future, please consider supporting Advent of Code and sharing it with others. To hear about future projects, you can follow me on Twitter. I've highlighted the Easter eggs in each puzzle just in case you missed any. Hover your mouse over them and the Easter egg will appear. Wow, there we go. Well, thank you everyone for following me on this journey. I will continue to keep streaming in the new year, probably doing more Ruby stuff, but maybe some fun web stuff as well. Yeah, that's it for me. That was a nice quick one to go out on. I kind of am glad that they didn't save the hardest for Christmas Eve here, so that I can go finish this scotch by the fire. So cheers everyone, see you later.